Hello friends, hope you all are doing well. So in this video, we will discuss important topic and frequently asked concept, which is residual solvent peaks in 13C NMR and why they appear as split signals. So the common solvent peaks which we use in 13C is like CDCl₃, DMSO-d₆, MeOD. So firstly, we will take a look at these solvent signals peak in 13C NMR. The CDCl₃ peaks generally appears around 77 ppm as a triplet, while DMSO-d₆ peak appears at 40 ppm as a septate, and MeOD, which is methanol-d₄ appears at 49.5, 49.8 ppm as a quintet, and acetone-d₆, so it generally shows two peak because of presence of two different carbon. One is as carbonyl and the other one is methyl. So the methyl carbon appears at 30 ppm as septate, and the carbonyl carbon appears around 209 ppm as singlet. So what is the key observation in these 13C NMR signals of different solvent? So in general, the compound peaks in 13C NMR appear as singlet. So will be no splitting or coupling. But solvent peaks appear as split signals. And this difference is very important for interpretation. Why does this happen? This is a core concept and also a very common interview and competitive exam question. The reason is 13C NMR spectra are proton decoupled. So carbon does not couple with hydrogen, and this is the reason compound peaks appear as singlets. However, the spectrum is not deuterium decoupled. So the deuterium, heavy isotope of hydrogen, is present in deuterated solvent. So that deuterium couples with carbon and shows splitting in solvent signals. So this is the reason, as a result, CDCl₃ as triplet, DMSO-d₆ as septate, MeOD as quintet, and so on. So the reason is carbon deuterium coupling. And why in acetone there is no splitting of signals at 209? Because that signal appear due to presence of carbonyl C double bond O. As it does not contain directly attached deuterium, so no coupling occurs and it appears as a singlet. This is a standard reference table that contains the 13C chemical shifts and patterns of different common solvent which we generally used in NMR for NMR spectroscopy. You can use this table for spectrum interpretations, exams, interviews, and for your research work. So, what is the real life importance of this splitting and everything? The question is very commonly asked in interviews, competitive exams, and PhD. In fact, this was also asked during a PhD defense. Final takeaway: 13C NMR is proton decoupled. So compound peaks appears as singlet, not deuterium decoupled. So solvent peaks shows splitting, and this splitting is because of carbon deuterium coupling. Hopefully you understood this concept clearly. So if you like the video, stay tuned for more NMR insights, and also if you want a video on any specific topic, please comment below. Thank you.